When we think about air pollution, our minds usually jump to things like smoke, smog, maybe even soot from a diesel truck. But what if I told you that one of the most common synthetic pollutants out there was something we couldn't see and, until very recently, couldn't even detect? Well, we're about to dive into a scientific detective story that's been hiding in plain sight all along.
So scientists have been asking this exact question for a while, and their search has turned up a brand new class of pollutant, one that, it turns out, has been right under our noses, or rather, in our noses, for decades.
Okay, so our story really kicks off with the discovery of this mysterious synthetic compound that was, well, showing up pretty much everywhere researchers were looking.
Now, these compounds belong to a family called methylsilicones. You might actually be more familiar with their most famous cousin, silicone. Yeah, that stuff. It's an incredibly useful material, right? We find it in lubricants, in agents that stop things from foaming up, and even in a ton of our cosmetics.
Now, this is where things get really interesting. Scientists already knew about the small kinds of methylsilicones, the volatile ones that evaporate easily from things like lotions or shampoos. But what they started finding was something totally new. These huge, really complex methylsilicane polymers inside tiny airborne droplets, aerosols. And the kicker? They were coming from a completely different source.
So, you might be asking, why did this new pollutant stay hidden for so long? Well, it was actually a pretty simple technical problem. The molecules themselves were just too big and heavy for the conventional lab equipment to even see them. They were literally flying completely under the radar.
So how on earth did they finally spot it? They used this really clever technique. Essentially, they just heated up the air samples to super high temperatures. And what that does, as this great analogy explains, is it's like taking a long, complicated bead necklace and breaking it apart into all its individual beads. Once they were broken down into smaller pieces, their instruments could finally see them and identify what they were. Pretty smart, right?
Okay, so identifying this new pollutant was a huge first step. But the next big question was, where on Earth was all of this stuff coming from? And the investigation, well, it led them to a very, very surprising place.
The researchers basically put on their detective hats. First, they went and took air samples from traffic tunnels. And bingo, they found really high levels of these big methylsilicones. But here's the crucial clue. They were always found right alongside another chemical marker, long-chain hydrocarbons, which are a known signature of engine lubricants. The two were always together, and that's a classic telltale sign that they're coming from the exact same source.
And there it was. The main source wasn't cosmetics or industrial products like everyone might have assumed. It was traffic. Specifically, the lubricants and oils used in our cars, our ships, and all sorts of other vehicles.
All right, so we've found the pollutant, and we know the source is traffic. But the story gets even crazier. Just how widespread is this stuff really? And what actually happens to it once it gets up into the atmosphere? And this is the part that's just wild. The researchers didn't just find it in one place next to a highway. They found it everywhere they looked. From a huge city like Sao Paulo in Brazil to rural farmlands in the Netherlands, and even in the forests and along the coast of Lithuania. This isn't just a city problem. It's a full-on global phenomenon.
So why does it travel so far? Well, it all comes down to chemistry. Remember those other hydrocarbons from engine oil? They tend to break down pretty quickly in the atmosphere. But these big methylsiloxanes, they are incredibly stable. They just don't break down easily, which means they can hang around for a long, long time and travel across huge distances.
And this brings us to the most important part of the whole story. Why does any of this matter? What are the potential consequences of having this super stable synthetic pollutant spread all across the globe?
First off, let's just talk about how much of this stuff is out there. These compounds aren't just some tiny trace element. In the places they studied, they made up between 2 and 4.3% of the total measured organic aerosol mass. Now, that might not sound like a lot, but in atmospheric science, that is a substantial chunk of the pollution we're breathing.
Yeah, the research paper puts it pretty bluntly. The amount of these methylsiloxanes we might be breathing in every single day could be, and I'm quoting here, substantially higher than other synthetic pollutants that get way more media attention. Let's actually see what that looks like.
And wow, here is the absolutely jaw-dropping comparison. On this chart, you see the estimated daily amount we breathe in for PFAS, the forever chemicals. It's about half a nanogram. For microplastics, it's around 12 nanograms. But then look at these methylsiloxanes. The daily dose in a city could be up to almost 1,500 nanograms. That's more than 100 times more than microplastics, and literally thousands of times more than PFAS. It's just a completely different scale. So here's the kicker. We're inhaling a lot of this stuff, but we have almost no idea what it actually does to us. Its toxicological properties are a total mystery. And beyond just our health, scientists also think it could have serious climate effects, maybe changing the properties of aerosols and even messing with how clouds form. These are massive, massive questions that we really need to answer.
And so that leaves us with this big, looming, unanswered question. For the very first time, we can finally see this pollutant. We know it's everywhere, a persistent byproduct of our modern world. But we are only at the absolute beginning of understanding what breathing it in, day after day, year after year, truly means for our health and for our planet.